So our learning target for today, I can examine side lengths and angle measures of polygons to determine similarity. So when we are focusing on similarity, we are focusing on what's called corresponding sides and corresponding measures. Before we begin that though, I want you guys to go ahead and get started on this warm-up. It's just these two questions right here that are pertaining to this map. Making sure that you understand that the map has a scale that 3 inches is going to represent 200 feet. So 3 inches on the map represents 200 feet in actual size of a park. And then on the map, each side of the park is 6 inches in measure. So that means that we do have a square map. So it's 6 inches for all 4 sides. So what you're going to do is for question 1, if Zara's distance to the park is 500 feet, then how long is that distance going to be on the map? So what would that measurement be on the actual map? And then if Zara runs around the perimeter of the park once, then what distance did she run? So how far actually did she run if she runs the entire perimeter of the park? Okay, let's go ahead and go over the answers. The first thing that we want to make sure that we have an understanding of is that we do have this scale here. We have the 3 inches to 200 feet. So that's going to be the scale. We also have to have an understanding that we have on the map that each side of the park is going to be 6 inches long. So that means that this is going to be 6 inches, 6 inches, 6 inches, and 6 inches. And then what we're trying to figure out is, for the first question, if her distance is 500 feet, then how long is that distance going to be on the map? So we're going to take that scale that we have here, where we've got 3 inches. I'm going to highlight that one in blue. We've got 3 inches that I'm going to go ahead and place on top of the scale. It's going to represent 200 feet on the bottom of the scale. And then we want to know how long is this distance on the map. So if it's on the map, is that in inches or in feet? Inches. So inches would be going on top. So we want to know how many inches over the 500 feet for the actual size. Okay, so we can set up a proportion to be able to solve, and then we just do our cross product. So we would multiply, we would do 200 times the x, and that would give us 200x. Then we can do 3 times the 500, and that would give us 1500. And then from there, we can just go ahead and divide. So we would divide both sides, in this case, by 200. And we would get that x is going to be 7.5 inches on the map. Okay. Then for problem 2, if Zara runs around the perimeter of the park once, then what distance did she run? So the first thing that we need to know is, what is the actual perimeter of the map? So the perimeter of the map is going to be all of these added together, right? 6 plus 6 plus 6 plus 6. Okay, or 6 times 4 if you wanted to do it that way. And that would come out to 24 inches. So we know that the perimeter of the actual map is going to be 24 inches. Because remember, perimeter means you add all the sides. So now we can go ahead and, again, take our scale that we've got. Our scale is represented as 3 inches is going to stand for 200 feet. So now we want to set it equal to 24 inches that we have for the map. We want to know how many feet is that going to represent for the actual perimeter of the park. Okay, so then we can again do our cross product. We can multiply 3 times the x, and that'll give us 3x. Then we can multiply 200 times that 24, and that's going to give us 4,800 or 4,800. And then we would just divide both sides by 3. And then we would find that the actual perimeter around the park is 1,600 feet. Okay, and there's other ways that you could have gone about solving for that as well. You could have done, okay, well, I know my scale factor could just be 200 divided by 3, and that's my scale factor, and then I would just multiply that to my, 24 inches for the map's perimeter. Or I could have done, 200 divided by 3 and multiply that by the 6 and then add all those together. There's different ways that you could have gotten it as long as you still got 1,600 feet. Okay? Any questions? All right, you're going to be doing a lot of these things where you're utilizing your proportions to be able to solve for missing measurements for today and for your quiz. So let's go ahead and talk about similar figures, what it means to be similar figures. So with similar figures, there are 3 very important characteristics. If we have scale drawings or scale copies, they are creating similar figures. So the similar figure, number 1, it has to be the exact same shape. That's the most important thing right there. They have to be the exact same shape. Okay, we talked about that before, that, yeah, we could have triangles, but if the original was a scalene right triangle and now you've got a copy being an isosceles right triangle, then it is no longer a similar figure, therefore it's not a scaled copy, a true scaled copy. Okay, so scaled copies create similar figures. Similar figures are going to have the exact same shape. They also are going to have corresponding angles that are congruent. Does anybody know what another word for congruent means? What's another word for congruent if I say it's congruent? Equal. Very good. So congruent just means that they are equal. So if I have a right angle, then the other one has a right angle. They're both 90 degrees. If I have a 30-degree angle, the corresponding measurement is going to be a 30-degree angle. Their angles will all be equal to each other from one shape to the next if they are similar. Now, when we're talking about congruency, so congruency has a very specific sign. When we use the word congruent, it's not just an equal sign. Equal is equal. Congruent is an equal sign with a little wave up at the top of that equal sign. Okay, so that is what we use to indicate congruency. You have an equal sign with a wave up above it. So you'll see that often for what we'll be using today. Okay, and then we've got corresponding side lengths. So your angles are all going to be equal to each other. They're going to be congruent to each other. Your corresponding side lengths are going to be proportional. So they are related by a scale factor. That means each side length in one figure is going to be multiplied by a scale factor in order for you to be able to receive the side lengths of the corresponding sides. Okay, so they will be proportional to each other. That means that every time you take the new and divide it by the old for every side measurement, they will all come out to the same scale factor. Okay, so let's take a look at an example. And I'm going to go ahead and draw a couple of triangles here. So bear with me on my drawing. We're going to go ahead and label this triangle A, B, C. And then I'm going to draw a smaller triangle, and we will label that one X, Y, and Z. Okay, and I'm going to go ahead and indicate that angle A has a measurement of 30 degrees. Angle B is going to have a measurement of 100 degrees, and then angle C is going to have a measurement of 50 degrees. Now notice that I'm drawing these little lines, right? The angle A, I only drew one line. Angle B, I drew 2 little arced lines, and then angle C, I drew 3 arced lines. Those are correspondence lines. Okay, we use those corresponding lines to be able to indicate that from one shape to another shape, these angles are going to correspond to each other. So for ABC, angle A is supposed to correspond with which angle on here? Madison? X. Okay, so that means inside of X, I'm going to go ahead and just draw one arced line to showcase that A and X are corresponding with each other, and therefore they are congruent. So here, when we talk about congruent corresponding angles, that means that angle A is congruent, so remember I'm going to draw my equal sign with a wave on top, to angle X. Okay, and that little angled sign looks kind of like a less than symbol, but not quite. Okay, what about angle B? Angle B is supposed to be corresponding and therefore congruent to what angle? On Y, right? So where Y is, I'm going to draw two arced lines. Okay, and then for angle C, the only measurement that is left, it would correspond to angle Z. So we're going to draw three arced lines. Okay, so that means that they are congruent to each other. Therefore, if A is equal to 30, what does X have to equal? Somebody whispered it. Huh? 30. Okay, they are equal to each other. They are congruent to each other. If B is equal to 100, then Y is going to be equal to 100. And if C is equal to 50, Z is equal to 50. Okay, they will have the exact same measurements there. All right, then we're talking about the corresponding side lengths, having that scale factor. So let's go ahead and say that line segment AB, that means in between angles A and B, it's that line segment. We're going to say that that is going to be equal to 10. I will say that line segment BC is going to be equal to 12. And that line segment AC is going to be equal to 30. Okay. Then I'm going to say that XY is going to be equal to 5. YZ, I'll say, is equal to 6. And then XZ is going to be equal to 10. Okay, now based off of that, I need to make sure that they are proportional to each other, that they do have a common scale factor. So that means that when I'm going from one shape to the next shape, if I were to divide new divided by old, it should be consistent throughout. Okay, now I don't know which one of these is the new one or which one's the old one. I have not indicated that. But it does not matter which order you go as long as you go in that same order consistently throughout. Okay, so I could say, oh, I'm going to take 10 and I'm going to divide it by what? By 5, because those are corresponding sides. 10 divided by 5, what does that equal? 2. I could also go and check my 12 then. If I do 12 and divide it by what? What would 12 have to be divided by? 6, because they are going to correspond with each other. That would come out to 2. And then I could take, oh, I meant to write 20, not 30. No, I meant to write 20 there. Okay, then I could take 20 and I could divide it by the 10, and that is also going to come out to 2. So the fact that they all come out to the exact same scale factor does mean that they are proportional to each other. You could do it in the reverse. You could do 5 divided by 10, 6 divided by 12, and 10 divided by 20, and you would then get 1/2 or 0.5 consistently through all. So you do know that they do have a proportional relationship, and their proportional relationship has a scale factor that is equal to 2, or in the other case, 1/2. Okay, so that makes it a proportional relationship. And again, corresponding sides, you cannot just choose any random side to pair up. They have to be corresponding to each other. And be mindful that corresponding sides don't always, like the shape's not always going to be facing the same orientation, meaning the same direction. It might be turned. So you have to make sure that you're reading the question carefully to see which one are they saying lines up. So an AC would line up with XZ. All right, any questions so far? Okay, let's go ahead and flip it on over to the back. Okay, so off of what we just discovered, what I want you guys to do is you're going to go through each of the examples. There are 2 examples on this page and then one more example, or sorry, 2 more examples on the next page. You are going to answer the questions. Are they the same shape? If they are the same shape, what are the congruent corresponding angles going to be? So saying like angle B matches with angle, X, and so on and so forth. And then what are the corresponding sides related to by the scale factor? So then you would indicate what the scale factor is going to be by showing exactly what we just did, which is to divide each of the sides by corresponding sides, okay, and show a consistent scale factor. If you find that it is not going to match up, then we know that it would not be a similar shape. So you're identifying whether these are similar by answering those questions. All right, so for the first figures that we're focusing on, first of all, are they the same shape? Yeah, they are the same shape. Okay, so that checks off. That means that that's one thing that we know that would make it a similar figure. Corresponding angle measurements. Do they have corresponding angle measurements? Yeah, they do. Okay, so we can check off on the corresponding angle measures because they do have corresponding angles. If we take a look here, angle A is going to be congruent to angle W, okay, because they're both 105 degrees, right? They're both 105 degrees. So here's angle A, here's angle W. They are both 105 degrees. We have angle B. Angle B is going to be congruent with angle X because they are both 45 degrees. Okay, so we have those are going to align. Okay, we've got angle C. Angle C is going to be congruent to what angle? C is congruent to Y, right? Angle Y, they are both 90 degrees. Okay, and then we have angle Z. Oops. Let me go ahead and make my little thing. Then we have angle Z, which is, and I'm just going to circle that one because I don't have enough room. We have angle D is going to be congruent to angle Z, okay, because they are both 120 degrees. Okay, so they are matching up. We do have corresponding angles. We have those equal congruency statements. What about corresponding sides? Are they related by a scale factor? Yeah, what's the scale factor? 10, right? The scale factor is going to be 10. So if we take a look here, we've got side AB and side WX. They have to align with each other. If we would take 110 and divide it by 11, that's going to come out to 10. If we take our next measurement, we've got, we'll go from B to C. That means that X to Y. We've got that 150 can be divided by 15. That is going to come out to 10. Then we've got this measurement here. We've got YZ, which is 40, and CD, which is 4. So we have 40 divided by 4. That's going to come out to 10. And then our last one, we've got WZ and AD. We've got 80 over 8. That comes out to a scale factor of 10. So yes, that is going to have corresponding sides that are related by a scale factor. So then that means we are dealing with similar figures. So yes, these are similar. Okay. All right, what about for the second one? Are those similar figures, yes or no? No, right? They are not similar figures. They are the same shape, right? These are going to be identical shapes, so that does check off for here. But then when we come to congruent corresponding angles, when we've got angle M and E, they are congruent. Angle M is congruent to angle E. But then we come to angle N and angle F. Angle N is not congruent to angle F. So the minute that you have an angle that is not congruent with its corresponding measure, then automatically you know that that's not going to be a similar figure, right? Angle N is 160 degrees. That's not the same thing as 155 degrees for angle F. So therefore, these are not similar. You don't have to go any further than that. Okay, you can stop immediately. All right, let's go on to the next page. Okay, so for here, for our next one, we've got same shape. Yes or no? Yeah, same shape. Yeah. Corresponding angles. Yes or no? Yeah, angles are corresponding. We're good there. So we have angle A and angle E. Even though we don't know the measure, those are congruency symbols here. Angle A is going to be congruent with angle E. Okay, then we've got angle B is going to be congruent with angle F. So angle B and angle F are corresponding. Then we've got C. Angle C, that's not a congruency symbol, but what symbol is that? What symbol does that indicate? Right angle, right? They are both right angles, so they are congruent to each other. Okay, and then we've got our last one right here. D is going to correspond with H. They are congruent. Okay, so we do have congruent corresponding angles. Those are going to match up. All right, and then what about congruent corresponding sides? Do we have congruent corresponding, or not congruent sides, but corresponding sides by a scale factor, yes or no? No. What's the scale factor? Not 1.5. So let's take a look. Well, let's check. Okay, let's start with measurement A, B to E, F. Okay, we're going to do A, B to E, F. So we'll make this one blue. Okay, so we have 15. Oh, well, I guess you did 15 over 10. I did 2 over 3 before, or 10 over 15. So you did this way. Okay, but it doesn't matter which way you would have done it. Okay, so yeah, 1.5, that could be one, or you could have had 2/3. So you could either have 1.5 or you could have 2/3. Okay, so 15 over 10, that would come out to 1.5. If we did 6 and 4, 6 over 4, that would come out to 1.5. Okay, if we do 9 and 6, 9 over 6 is going to come out to 1.5. And then if we do 12 and 8, 12 over 8, that's going to come out to 1.5. Okay, so it does simplify out. So yes, these are similar. Okay, I'm actually going to skip the last one just because, yeah, all of them are, it's the same shape. It all has the same equal sides because they're all 90, but they aren't going to be corresponding. They're not going to be corresponding. If you check that I'll just show it to you real quick. We've got the 8 and the 18. If we do 8 over 18, so 8 over 18 is going to come out to 0.4 repeated. Okay, but then when we do 12 and 24, 12 over 24, that's going to come out to 0.5. Okay, and those are not equal. So with them not being equal to each other, that means that this is not similar. All right, real quickly, I want you to take page 3, flip it over to the back. There's nothing on the back, but we're going to do a couple of quick little problems to help you with your quizzes that you're going to be doing later. So here, I'm telling you that these are similar figures. These are similar figures. We want to go ahead and solve for x. So we can set this up as an actual proportion. So knowing that we've got corresponding sides, 10 is going to correspond with the x. 12 is going to correspond with the 42. So we can set it up as a proportion. where we have 10 over 12 for the triangle that we know, and x over 42 for the triangle we're trying to figure out. And then we can go ahead and do the cross product. We can multiply 12 times x to get 12x. We can multiply 10 times 42, and that's going to give us 420. And then we can go ahead and divide. So we would divide both sides by the 12, and what is 420 divided by 12 going to come out to? It's going to come out to what? Okay. All right. If we do the same thing for problem number 2, same thing. We have 88 is going to correspond with 50. We've got 176 is going to correspond with x. So we want to be able to create our relationship here. We've got 88 and 50 are going to align. 176 and x are going to align. So we've created a ratio for the triangle we know and a ratio for the triangle that we're trying to figure out. And then we can do our cross product. So we can do 88 times x, and that's 88x. We can do 176 times the 50, 8,800. And then we can go ahead and divide by the 88, and we'll get 100. Okay, so you can do your proportions to be able to solve for missing measurements too, knowing that you have similar figures. Because again, similar figures are going to have the same scale factors. All right, you have loaded into Google Classroom at this time. You've got a quizzes. It's just 15 questions. It needs to be finished before class starts tomorrow.